Hello guys, welcome to Houdini Made Simple. In this tutorial, I'm going to be covering how to control the viscosity of the fluid using the temperature attribute. It's a simple setup useful to create effects like lava or chocolate. I focus on the sim and the meshing process, but if you are interested in the shading and rendering process, please leave a comment and I'll cover that in another one. Let's get to it. Okay guys, let's start with a quick review of the setup. We have an emitter, in this case it's a sphere with a mountain. I transformed this to be over the big rock. I'm gonna be putting some fluid and it's just moving left, right, and then I created a flip source. I already linked the particle separation and the voxel size to the one in the .NET, and then with the point velocity I created some velocity to the left and also added some noise to have a more organic emission. And then inside the .NET I already set up the collider. In this case it's going to be a big rock on the bottom using volume collisions, and then I have the volume source. Everything is by default, and also the flip solver I didn't change too many things. So in order to control the viscosity by temperature we have to do a few things. First we're gonna go into the flip solver under the volume motion tab, and on the viscosity tab we're gonna enable viscosity first and also make sure to have viscosity by attribute enabled too. And then we're gonna go into the flip object and enable add viscosity attribute and also add temperature attribute. If we hit play right now, everything should look the same because we haven't set any attributes, so let's start doing that. In order to test if the viscosity is working, we can use an attribute create a node, and on the name of the attribute we can change this to viscosity. And we can try a high value on the value box, so we can type 1000, go back into the .NET, hit play, and we should see now that the viscosity is working, although we have the same value along the time frame. So back to the attribute create, we're not going to be using viscosity to control the viscosity, we're going to be using the temperature, so we're going to create a temperature attribute and we're just going to start with the value of 1. And back into the .NET, we're going to create a gas temperature update node, and we can connect this into the last entry, in this case into the merge together with the volume source. And we can also go into a flip object and under the guides tab make sure that display the temperature attribute, and we can change this into black body so we have like a different shade of colors to display the particles in the viewport. So if we hit play now, we can see how the color and the temperature is changing over time, meaning that as the temperature gets colder, we're gonna have a more yellowish tone. Eventually it's gonna be red and then black. So we can play with this using the gas temperature update. So what this node is basically doing is dropping down the temperature attribute, and as it gets colder, the viscosity is gonna start going higher and higher. So in this case we have 0 to 10,000. I'm gonna change this to 1 to 8,000. And again, when the temperature is 1, we're gonna have a viscosity of 1, and as the temperature starts dropping down and gets closer to 0, we're gonna have a viscosity of 8,000. So I want this to get a bit cooler, a bit faster, so I want to start playing with the cooling rate. In this case I'm gonna put 0.75, so we see the temperature going down a bit faster, and we can start seeing that as the temperature gets colder, and you can see the color is getting more orange and red, the fluid starts being way more thicker and sticky. So now we officially have linked the temperature and the viscosity attribute. And we can check this on the geometry spreadsheet when we're gonna see the value. So we can click on the flip object, go into geometry, and on attributes let's isolate the viscosity and the temperature, so we only see those two. And as you can see, when we see a temperature closer to 1, we see we have a viscosity really low, and as the temperature starts dropping down we have a really high viscosity. So as the temperature gets close to 0, we're gonna have a more viscous fluid. So feel free to play with this value, especially with the cooling rate, to control how fast the temperature is gonna drop down, and also you can play with the range of the viscosity attribute. Another thing we can do on the emitter is to create some noise on the temperature. So I want to create an attribute noise, and over here we're going to get a float attribute. It's going to be affecting the temperature, and basically we want to have different values as starting values, so we don't have always a value of 1. We can play with the range. In this case I'm going to play with 0.5 range, and let's play with the element size. And we can create the blast node to delete the surface SDF just to display the particles. And then we can also go to the geometry spreadsheet, so we see the range of values we have. So we can type temperature on the attributes to isolate that one, and then we can see we have values from almost 0.7 to 1.3. And if we hide the geometry spreadsheet and go to the visualizers, we can edit the temperature and use that range 0.7 to 1.3 to display the temperature and see that initial noise that we have on the temperature. So back to the .NET, if we hit play, now you can see that we have some initial noise on the emitter. So we can see we have different temperature and we're going to have different viscosity values. That's going to give us an extra detail and it's going to look a bit more organic. So this is looking good. Before seeing this in high res, I'm going to tweak some values, especially on the oversampling. Remember, when working with viscosity, it's always a good idea to tweak the oversampling so we have more particles. So I want to try with the value of 20, and the rest I'm going to add also the attribute, the vorticity attribute, and also in behavior I want to add the ID and the age particles just in case. And that's going to be good enough. And then on the interpolation attribute, I'm going to type also viscosity, and the rest is going to be by default. For the particle separation, I'm going to try with 0.01, and if it is still too fast, I might go even lower. So now everything is ready, so I'm going to create a DOP import fields to import the flip simulation. I'm going to drag the .NET, and under the DOP node, we can bring the flip object node. And I'm going to select under preset the flip fluid preset. So let's create the fluid compress so we can save some space on disk. And we need to link the particle separation from the flip object. Just 2 comments before moving on. I did went to 0.6 with the cooling rate, and also on the flip object I'm gonna try 0.008. I think that's gonna give us like a better result. So I wanna copy this parameter and paste relative reference in the particle separation. I'm going to deactivate the code bandwidth, and before moving on we need to make sure that we keep attributes, we keep the temperature attribute. So I'm going to type temperature. There we go, we have the viscosity and everything is okay. So now we can create a file cache. So now everything is ready, so let's hit save to disk and I'll be back in a few minutes. Okay guys, so this just finished caching, so I'm gonna create a particle fluid surface. First things we can do after we connect this into the input is go and link the particle separation to the one in the flip object. So I'm gonna copy and paste relative reference into the particle fluid surface. And then in convert to, we're going to use the particle option so we can display the particles, and on the visualizers I'm going to activate the temperature so we can see the color. Let's make sure to check that box, and now we can display the high-res cache with the temperature attributes. And the high-res cache is looking pretty good, so I'm happy with the end result. So I'm going to move into the meshing process. Okay guys, in the meshing process I like to go a bit lower with the voxel scale to have like a better resolution on the mesh. Also go a bit lower on the influence scale and the droplet scale too. You can find more information about this on my viscosity meshing tutorial. And now we can go and create the mesh. And finally, let's make sure that we transfer the attributes, the temperature and the viscosity. So we have those, especially the temperature, we're going to be using that for the shading. So we're going to type those in the transfer attributes, and there we go, we have the mesh looking good. And finally we can go to filtering and we're going to activate dilate and erode. This is gonna clear some of the artifacts that you might have. And now we're ready to cache, and I'll be back in a few minutes. So caching the mesh, it took about 7 minutes, so pretty fast. This is the final result. I'm pretty happy with the behavior, how the fluid, as it gets colder, you can see that it's getting thicker and way more sticky. So it's looking good. We have some nice details overall. And depending what you are after, you have a lot of room to play. Again, you can play with the cooling rate. Maybe you want this to take way longer to get cooler, so you're gonna have way more splash, and then as the fluid gets cooler, then it's gonna start getting thicker. You can even play with even higher values on the viscosity. So again, this is just the base, and this is my final render. I rendered this in Karma. It's still pretty low res, but it's looking good. So if you are interested on knowing how to create the shader, please leave a comment and I can make a tutorial on that. Although it's not too advanced, we do need to consider some stuff in order to set up especially the lava shader in the proper way. And again, you can use this control the temperature not only for lava but also for other types of effects like chocolate. A lot of times it's going to start hotter and then it's going to get colder, but in this case I use lava as an example. So guys, this is it for today. I hope you enjoyed the tutorial, and if you have any question, feel free to leave a comment and ask, and I will see you on the next one.